I'm going to tell you about a new geometry. I want you to describe the geometry. I want you to describe the geometry with one word, okay? We have a plane here, okay? And you can walk on the plane, all right? Then in this area, it's dark, okay? Yeah. And in this area, it's dark. And you walk over here, you walk into the darkness, and then you realize that you're over here. Once you penetrate into the darkness a little bit, you suddenly are over here. And the way you know that is by looking at this gentleman who's laughing at you. Okay, how would you describe this geometry? In the first part of this two-part series, Hrithvik, Arshad, and I discussed the waterfall hypothesis. The idea that gravity is caused by the Earth and other gravitational objects sucking in the ether. In the second part, we discussed a possible problem with that hypothesis. And in this third part of the series, we will now dive into an alternative way of thinking about gravitation. First, we will discuss examples of non-Euclidean geometries and what non-Euclidean geometries could actually physically mean in reality. We then discuss my hypothesis regarding the underlying nature of space and how gravitation could alter space. This and many more interesting side quests are coming up here on Inductica. So consider this hypothesis I was telling you about before, okay? There's a lot of great things to suggest it, but there's a problem. I'm forgetting how deep I got into explaining the problem with this hypothesis. It looks like Hrithvik wants to tell me.
Yeah, so I was just going to say the main problem from the last call we talked about this was the fact that the ether was moving, it was accelerating, right, with respect to space. So the question then arose, is the ether a property of space, or is like the ether fundamental to space itself or not?
Yeah.
Or wasn't it, is space a property of the ether?
Ether, yeah.
Okay.
Yeah.
Yeah, right. And what the hell would I even mean? Like, is space a property of the ether? Like, here's specifically what I mean. Well, it could mean a number of things. So you could just say that. You could just say, well, if space is a property of the ether, then it doesn't make sense to talk about the ether moving.
Yeah.
But let me give you one specific understanding of what it would look like for space to be a property of the ether.
Okay.
Space, in my view, is a relationship between entities which dictates, and I think this is the right view, by the way. I think this is the view that, it's not just my view, like this is the view that the evidence supports, and anything that goes beyond this is something the evidence does not yet support. It doesn't mean it's wrong, but it's like I'm being minimal about like what does the evidence give us certainty of, and here's what I think it gives us certainty of. That sometimes some entities can act on one another and some can't. If they can, then that's called being next to one another. And so like that's what space is. Okay, now what would that mean for an ether? Well, if indeed all entities are waves in the ether, then space just means different parts of the ether. So you can't talk about well, maybe you could, but if there weren't any deeper elements of space than that, then you can't talk about the ether moving, because movement means a change in location in the bulk of the medium. Now, or, I mean, this is possible too. There's some kind of substrate that there's some sort of like spatial substrate. Hold on.
Yeah.
I've already said this before, I think. Like there's some sort of secondary space that the ether is moving through. And then, well, actually, here's the easier one to think of. Maybe space just isn't a part of the ether.
Right.
And then the ether moves through space. And then some entities move through the ether. It's completely possible, but I actually think that the idea that space is a part of the ether, I think it makes less assumptions and is therefore more likely, a la Ron's book. But even if that isn't the case, it's still another possibility we need to be aware of. So this is not a refutation of this ether flow hypothesis. It is rather, well, you could view it as a refutation because it shows that it's one thing that makes us uncertain of it, because there's other possibilities that explain the same results.
Right.
So
I did think it was interesting because I thought the original definition of the ether by Aristotle was the stuff that makes up space. I'm not 100% on that. But so I was wondering why later on, I guess not just you, ended up using it to denote the medium that electromagnetic waves propagate through.
Oh, the only contexts in which I say that are contexts where I'm trying to confine my, oh, how cozy. Are contexts where I'm trying to confine my discourse to like a very delimited subject matter.
Okay.
Like in the case of my last video, I only really proved the luminiferous ether. I didn't prove some sort of broader ether that quantum phenomena are a part of. I think I could, I just didn't do it yet. So whenever I say that, it's just that I'm delimiting my discourse is all I'm doing.
Okay.
Yeah.
Okay.
Yeah, that's a good question. So let's see. Let's see. What's next? Damn, there was another thing I wanted to say. Have I mentioned Parmenides in this context yet?
I don't think in this context, no.
So Parmenides, Parmenides thought that there was a plenum. Oh, and by the way, when I say plenum, I'm referring specifically to the hypothesis that space is like an aspect of the ether. So when we talk about like the ether moving through space, I use the word ether. When we talk about a medium that is like the origin of space, then I use the word plenum, actually.
I see.
Yeah, and the reason for that is because Parmenides used the word plenum, and it's very akin to what Parmenides, because it's pretty much what Parmenides was thinking. Parmenides basically said there is no nothing, therefore everywhere has a something. Therefore the universe is this solidly packed slab of matter.
Right.
Which in some sense is true, but I think he took it a little too literally. And so he ends up saying things like motion is impossible. Why? Well, because everything's just stuck. Like nothing can move because there's nowhere for it to go. There's just cosmic gridlock in every direction, so nothing can move. So there's two ways to understand Parmenides here. Number one is that he took his hypothesis. Well, it's not that he took his hypothesis too literally. It's that he took certain concretes about the physical world and extended them into contexts that he couldn't assume they actually extended into.
Yes.
Or you can interpret Parmenides as thinking very deeply and identifying a real truth here. That in some sense, in some naive sense, nothing moves. And if the plenum hypothesis is true, he's kind of right. You see, like, nothing's literally moving. The plenum parts stay where they are. It's only the oscillations in the plenum parts that change their positions. So I'll introduce one last thing, which is, if this is the case, then how can we think about how could we understand general relativity then?
Mm-hmm.
Because it's like this picture I've shown you is pretty compelling, but if the ether can't move, if the parts of the plenum cannot move, then where does that leave us? I have a proposal, a modest proposal. We should eat our children. Okay, so here's the proposal. So what I'm going to do, bear with me because this is probably going to sound a little insane, but it totally connects back. The idea is that space is an emergent property, basically. That there is a thing that has an identity, and the identity gives rise to space. That like space itself is not this like fundamental aspect of existence that can't be reduced. I mean, so by the way, maybe it is.
Right.
But it doesn't seem like it because of general relativity. It really does seem like spatial relationships change. Wait a second, is that true? Isn't it enough to just say that entities deform? It seems to be that spatial relationships actually change.
Yeah. As in, it really, when we measure the distance between two objects within certain reference frames, and then we do it in another reference frames, like it seems as though the distance between the objects themselves change, right? The position of the objects relative to each other.
Yeah, I'm going to actually, before going to my kind of crazy idea, I'm going to talk about some facts in general relativity that I think lend themselves to this.
Okay,
sounds
A
good.
straight line is defined as the path light takes. Okay, now you may wonder why that is, and here's why that is. When you judge something to be straight, it's that if you like do this, basically, this part appears to be at the same location as this part. Why?
Yeah.
Because the continuation of the matter goes in the same direction light propagates. Okay? Now, what makes this kind of funny is that there's two things. Like, first of all, light changes direction, but that's when it changes media. But another thing is that but you could just stipulate, okay, but fine, but like it's the direction it goes when it's not going through a media. You could get even more technical with this, and I think I would choose a different definition, a broader definition, as I would say a straight line is the path along which momentum is conserved.
Right. That's the definition that I think I learned.
Someone else came up with that?
Yeah, my special relativity professor came up with that.
He came up with it, or he told you?
She came up with it, and she might have. I don't know if she came up with it actually. She might have just told me, but I know for sure.
But that's really cool, man. Yeah. I didn't know someone else thought of that. Yeah, I mean, so that's. I mean, that is a very. That's a good idea. Yeah. Anyway, because it. Okay, now, if that is really the case, then in general relativity, a straight line becomes curved.
Yeah.
Right? Now, I put that in quotes because it makes no goddamn sense. But how can we make sense of that? Here's part of it. Now, I mean, well, actually, our goal is not to make sense of that statement because it just doesn't make sense.
Right.
Our goal is to understand, like, what are we trying to understand when we say that statement?
Yeah. What do people really like experience when they came to that conclusion? Like.
Unfortunately, I'm not going to be able to give you an answer to that question. That's a good question, but I don't have an answer to it. I have a different way of wrapping my head around this. Okay.
Right.
In general, and so maybe that makes it invalid, but I'm just going to give this to you. Use it how you will. See,
okay.
Maybe you can poke a hole in it. So here's what is it? So the way I asked was like, what does it mean for space to be curved? Now, It doesn't mean anything because it's flawed. But what are we trying? Like, what kinds of facts are we trying to point to? Okay. Now, I watched this video. I have no idea why YouTube gave me this video, but I froze when I saw it because the video was called Non-Euclidean Doom. Doom is a video game, a shooter game.
Oh.
Yeah.
And have you seen this? Have you seen Non-Euclidean Doom?
I have.
No, I haven't.
Google it, search it, and watch. Not right now. Just watch it sometime. Okay.
I was going to. Yeah.
Yeah. It's too long, but you'll definitely benefit from watching the whole thing. So
Okay.
there's I mean, it's not that long. It's like 10 minutes. You can skip through and kind of get the important parts. But basically, it was this, basically what this guy did is he took Doom and he programmed a different value of pi into it. Okay?
Yeah.
Now pi is, I believe, a physical constant.
Right.
Yeah, I've said this before.
Oh no, it just makes sense.
I'm
not
glad
to-
it makes sense to you, because a lot of people would say, like, well, no, pi is a mathematical constant. It's not. I think it's physical. Now, I think it applies to other mathematical facts. But,
Yeah.
like,
It's
you can differentiate pi qua the pi that shows up in, like, let's say the answers to the Riemann zeta function, or the outputs to the Riemann zeta function, versus the pi that physically governs spatial relationships. Okay, qua that second pi. Let me. What? Told you not to call me. Too
Is your
bad.
landlord calling for rent?
It's No, they're trying to contact me about my car's extended warranty, and I know this stuff is super important. So, okay, so it's a physical constant. Actually, let's turn it to you guys. What do you think pi means as a physical constant?
So the ratio of diameter to circumference, right?
Yeah. Now, I prefer to think about tau.
The circumference of a circle with radius equals 1.
Sure. Now, both of these are valid definitions, but I want to say that they're not quite as essential as mine. If you guys need to talk about something, you could take a quick sidebar.
No, I was.
Don't treat this like class. You can take a sidebar if you need
No,
to.
sorry. It was a really stupid debate. It wasn't radius equals 1. It was diameter equals 1. And Ershad was like, because I said the circumference of a circle with radius equals 1, right? That's not pi. That's
Okay. What? Yeah, I don't give a.
Yeah.
Yeah. Okay. I see. Okay. So I prefer tau. You ever heard of tau?
Yes. It's 2 pi. It's
Oh, okay.
Yeah.
Oops. It's this.
Oh, interesting. I haven't seen that before.
Yeah.
What is numerators?
Everything in math gets way easier if you use tau,
Oh.
because then this is quarter tau, and this
Oh.
is half tau, and you don't have to hate yourself for an entire year while learning pre-calc.
I
Yeah.
see. Yeah, that's so much better.
Yes. Yeah, a lot of things. The only downside is that the area of a circle becomes this, I think.
Right.
Yeah, but
then just the
whatever,
circumference
man.
becomes easier.
What?
The circumference becomes easier.
Exactly. Yeah, it's a wash. It's a wash, because then... Yeah, anyway.
Yeah. My physical constant was tau, not pi, when I said r equals 1.
There you go. That's what it should be anyway.
Yeah.
So, here's how I would explain it. If an entity moves in such a way that it maintains a constant distance from a second entity, if a first entity moves in such a way that it maintains a constant distance from a second entity and comes back to its original location, how far did it go with respect to the distance?
Yeah, you can define a perfect circle based on circular motion.
Yeah. Well, you use the fact of circular motion to derive circular motion, I guess.
I'm using the fact of circular motion to describe this constant that governs other spatial relationships.
Yes.
You did it in different ways. I feel like mine is more essential, but I'm not going to debate with you. Okay, maybe you already feel like you agree. I don't know for sure. It just feels that way. But yeah, maybe I'll think about that later. There's a reason I felt like saying it this way. I think
we could even just take the next step and say the path that's traveled by this particle is defined as a circle.
Right.
That has already been done, I believe, because a circle is defined as the points that are equidistant from a certain point in 2 dimensions.
It's interesting because circles are taught in school as, or based on like approximations of physical circles or physical circle seeming objects you'd find out
That's
there.
correct, though, because that's the inductive basis of a circle.
Okay.
I learned about circles by looking at spheres, and then I thought, what is the path around the outside of this?
Yeah,
sphere?
something like that. You mean that's how you learned about it as a child? You mean?
Yeah.
Yeah. I mean, I think everyone, you look at the moon or you look at like an eyeball, stuff like that. Yeah. So okay. Okay. Now, in general relativity, there's these curved geometries. Okay. Now, what does that mean? How could we make that make sense? Now, once we did, we would not call it a curved. Well, maybe we would. No, we shouldn't call it a curved geometry. Okay. Let us now talk about. In order to introduce this concept, I'm going to talk about an alternate geometry. And what I mean by this is I mean differing rules of space. Different rules for how... Now, the standard rules of space are Euclid's 5 axioms, 5 postulates, okay? I'm forgetting what order, but basically, one of them is you can draw a line as far as you want. Okay, what's another way of putting this? This means there is no known edge of space. Maybe there is, and when we get there, we'll talk about it. But until then, this is one of the rules of space. You see what I'm saying?
Right.
You can walk as far as you want. Okay? Another one is... What's another one? Is it the definition of a circle?
These at one point in time, I forgot.
I think another one is that the shortest distance between 2 points is a straight line. I think that's another axiom. Damn, I'm forgetting. Okay, now, what would it look like? Oh yeah, that is an axiom because I'm remembering my thought experiment. What would it look like if this axiom wasn't true? This axiom wouldn't be true if you reached the edge of space. Be sci-fi here. What would it look like if this wasn't true?
Oh.
Ooh. So, I'm imagining probably some Vsauce video where he bent a paper and then with 2 dots on it.
If the paper was bent, I would contend that that's still a straight line because the relationships between the parts of the paper are a certain way and you can proceed in a straight line.
I see. Yeah.
Okay, I'll give you a hint. The cake is a lie.
I haven't seen enough sci-fi.
You're probably too young for this game. The game's called Portal.
I know.
I've heard of the game.
No, that is not. We're not too young for that. I'm just not a gamer, and I don't think he's.
I used to be.
So if there was a portal here, a sci-fi portal, I'm not saying this actually exists. This is a purely sci-fi scenario. And then there's the exit over here. Then, I mean, that's not the shortest distance either, but you can see that the shortest distance between these 2 points isn't a straight line. If there's a hole in space and then an out hole over here, it would violate that axiom. Okay, there's no evidence that shit exists at all, but it's just it's a fact that it doesn't exist, and part of our way of grasping that is this axiom that the shortest distance between 2 points is a straight line.
Do we know for sure it doesn't exist?
There's no evidence of it, and
I see.
so I mean, it's the same as the edge of space. Like maybe we'll find it one day, but until we do, these are the laws we know of.
Mm-hmm.
Although laws is not quite the right word as we've discussed before, but I'm not sure how else to say it when you're talking about spatial relationships because they seem pretty ubiquitous. But anyway, I mean they would be characteristics of the plenum probably is what they would be. They would not be laws. They would be characteristics of the plenum and the way that entities must move through the plenum. Okay. Now I'm going to propose to you a geometry Okay. I'll tell you one more because this one's really important. You remember
Yes.
this one?
Yeah.
So if you have two parallel lines, then the difference if you have two parallel lines, or if you have two lines that never meet one another, let's say that.
Right.
If you have two lines that never meet one another, and then you cut them with a third line, the difference in direction between 3 and 1 is the same as the difference in direction between 3 and 2.
Yeah.
And that's what
direction means angle.
Angle, yeah.
I'm being like a little bit pedantic in order to like really break down what all of these things mean, to leave nothing to to the inaccuracies of floating abstraction.
Yep.
So that's another postulate. Okay, I'm going to tell you I'm going to tell you about a new geometry, and and I want you to describe the geometry. I want you to describe the geometry with one word, okay? And it doesn't have to be a perfect word, but I'm sure you'll be able to think of the word. Okay, here's the situation. We have a plane here, okay? And you can walk on the plane, all right? Then in this area, it's dark, okay? Yeah. And in this area, it's dark. And you walk over here, you walk into the darkness, and then you realize that you're over here.
I see.
Once you penetrate into the darkness a little bit, you suddenly are over here. And the way you know that is by looking at this gentleman who's laughing at you.
Mm-hmm.
Okay, how would you describe this geometry?
So you're walking along a cylinder.
Yes. Gunnar, if you remember Gunnar from our other meeting, Gunnar figured this out, and I got so excited when he knew what I was talking about. I was like, I slammed the table, which scared him. And nice. I was like, yes! Okay, so, great. It's a cylindrical geometry, okay? Have you seen the Matrix Revolutions? Wait, Matrix Resurrection? No, that's the bad one. The third Matrix movie.
I've only seen the first.
I haven't seen it.
The first three are really good, are good. So all three are. Don't watch the fourth. Don't even speak of the fourth. We need to condemn that to the ash bin of history, so as to not sully the name of the other three movies. Okay, so okay now. So based on this, you can so here's what I'm trying to capture here.
Yeah.
When you change position,
mm-hmm.
your position with respect to other things changes.
Yes.
What are the rules for how that works? I think that's geometry.
Oh.
And a non-Euclidean geometry is when those rules are different than we are accustomed to.
So, what are the rules we're accustomed to?
They are summarized in Euclid's 5 postulates. I'm not sure how else to... So again, here are 3 of them.
Yeah.
The other 2 are a little hard to wrap your head around, if I'm remembering it. I don't want to spend time with them, but like...
Yeah.
So one thing I'll tell you is like in a curved geometry... In a curved geometry, we're going to talk about what curved actually means in a moment. What I think it means. It turns out this postulate doesn't hold in a curved geometry, okay? In a cylindrical... what's a little confusing here is that a cylinder doesn't count as curved.
Oh.
Because this postulate does hold on the surface of a cylinder.
Huh.
Yeah.
Yeah. On the outer label surface of the cylinder, so long as you don't, stray out of the space.
Right.
I took a differential I took like the first lecture of a differential geometry course, I think, and there were like proofs like this, like prove that X applies here, or X axiom applies here.
Yeah. That's I somehow absorbed content of that kind from college, and that's kind of where this is coming from. I don't remember when. I didn't take a course like that. It was like something that was like briefly mentioned in my GR class, I think.
Oh, okay.
Yeah. So again, now let me tell you about non-Euclidean doom for a second. In the game, the character's moving around, okay? Because that's what you do in a shooter game. And when he did, the objects in the room seemed to slide around. Why? They weren't sliding. They appeared to be sliding around. They weren't, though. They appeared to be sliding because a change in the character's position led to a non-standard change in the relative position of other entities, which looks to our Euclidean intuitions like, oh, the objects slide around when you move. But I don't think that's what's happening. I think it's that you get what I'm saying. It's this other thing that I think is what's happening. I think. This is all kind of just intuition strung together. Like, it all needs to be validated. I have to really emphasize that this is all just kind of a flight of fancy. It might be a very productive flight of fancy, and that's why I'm telling you, but it needs to be checked.
Yeah.
So, okay. Now we're going to contemplate, in order to fully understand this, we're going to contemplate what it would look like to be on a spherical geometry.
Okay.
Now, why do I keep putting quotes on this? I'm putting quotes on this because in this situation I have drawn, there is no actual cylinder. We can call it a cylindrical geometry, but all we're saying is that the space is like that of the surface of a cylinder.
Yeah.
Right.
There's some similarity between the two spaces. Now, what do we mean by space? We mean a relationship. We mean, well, the geometry is that of a cylinder. And what do we mean by geometry? We mean, at least in part, we mean the way a spatial relationship changes, the way that all spatial relationships change with respect to one another. If I'm the Doom character and I move away from the dead demon, then what is the spatial relationship between me and the box of ammo?
Yeah.
How does it change now as a result of that?
I have a question, actually, based off of this. So, a lot of the early inductions I think we did related to the Earth being a sphere, right? When we were measuring distances to stars and stuff like that, we assumed a Euclidean geometry, right? Like a lot of astronomy is based off of the idea that we're in a Euclidean geometry. At least early astronomy is. Now there's a few more advanced methods being used. So would you say that those inductions weren't valid for that point of time because they didn't rule out the idea that there's a non-Euclidean geometry that we live in?
They were 100% valid because at that stage there was zero evidence of non-Euclidean geometries.
Okay.
And when one assumes a Euclidean geometry, it's true that someone could say, hey, wait a second, what if something new is actually happening? And then to that you can respond. The objectivist response is you have no evidence that something new is happening in this case.
Right.
Ron has a different response, which I think is better. I think the objectivist response is pretty good. I think Ron's is better because sometimes new stuff does happen and we need a way of dealing with the possibility that new stuff could happen.
Yeah.
And Ron has a way of literally calculating the odds that a non-Euclidean geometry would happen.
Okay.
And the odds are astronomical. Once you think about the evidence that you have and the probability that you will come across non-Euclidean geometry, having had an entire lifetime worth of Euclidean geometry, it becomes astronomical. But then, of course, non-Euclidean geometry does eventually crop up. So I think it may not be necessary to actually describe general relativity with non-Euclidean geometry. It might just be a giant red herring. But I don't think so because of what you're about to see in a few minutes. Yeah,
makes sense. I'm with you so far. I think what we've gone through so far was basically the first lecture I watched on YouTube. I didn't go to the physical class in college for the motivation for differential geometry. It wasn't presented as well as you presented it, being honest, but this is what I gathered from it.
That's interesting because I'm not attempting to I'm not. Well, I guess I am. I was about to say I'm not attempting to like give a basis for non-Euclidean geometry, but I guess that's exactly what I'm doing. I'm asking like, what the hell would it mean for non-Euclidean geometry to really mean something?
Right.
Yeah.
Like why? It is really
why? Yeah. Okay. Now, in order to further concretize what non-Euclidean geometry could mean, let us now understand a spherical geometry.
okay.
Spherical.
Actually, 1 second before we go there, I just want to say something. That's making me a little uncomfortable. I feel like saying it's like the surface of a cylinder, but it's not actually the surface of a cylinder. It feels like a little weird to me to say that because let me think for a second. Why does it feel weird to me? When there's a common property, right, of two things. Like when we see there's a common property of how space behaves, and there's a common property of how it is like to be on a cylinder. My mind usually goes to there's some equation or some common relationships, like somewhere down the line.
There's something in common between the two.
Right, between the properties of space itself and the properties of a cylinder. So it feels weird to say that these are like completely disconnected things. I guess they aren't because they share some relationship.
That's a good point. Let me patch this hole.
Mm-hmm.
Yeah.
There's two senses we could use the word cylindrical.
Yes.
First, we could mean the set of spatial relationships that are like that of the surface of a cylinder, the outer label surface of a cylinder.
Yes.
We could just change the word cylindrical to mean that.
Yes, I see.
I don't want to do that, though, because cylindrical means shaped like a cylinder, and there are just things that are shaped like cylinders out there.
Yeah.
So that's it. Because so like we need separate words for these things. Like you can choose whatever word you want, but they need to stay separate. That part needs to stay separate.
Makes sense.
Yeah. So yeah, I think Okay. Good question. Okay. Spherical. I will leave it to you guys. How would you describe a spherical geometry?
So
this is hard.
If you walked in any direction, you would eventually end up at the same spot.
Okay, good. That's true. Tell me more. That's the same as a cylinder, though. So that was a gimme because that was easy, right?
Well, not just
go on.
Because a cylinder, it's only in one direction where that would happen, right?
Yeah, if you walk north on a cylinder. Yeah.
That's true. Yeah, that's true. Yeah, that's a difference. This is by far the easiest feature, I'll tell you.
Okay.
You got it, though. Good. Keep going.
So, also, I guess if two people walk, this is first phrasing. If two people walk, or if two entities move straight, the distances between them would, well, I don't know which they'd do first, but they'd increase and then decrease, or decrease and then increase.
Well, I like where you're going with this. I don't think that's true, though. I think you've made a mistake. Rivik?
I was going to say it depends on which direction they walk, right? I think... So, did you say necessarily different directions?
No, I think
you said parallel.
Yeah, parallel.
If they walk parallel, wouldn't their distance between them stay the same?
Well, I'm thinking of two ants crawling on the surface of a sphere. So I'm thinking of... Oh, yes. That's that. Yeah, it would.
They would stay the same distance. Something weird is going on in this situation, though. Think about. Okay, I'll give you a hint. Imagine one ant was walking on the equator, and the other one was walking slightly north of the equator, and they were walking west.
So then the ant that was north of the equator would have to walk a shorter distance to arrive back at the same spot that than the ant that was walking at the equator exactly.
Yeah.
The distance between them remained the same.
So let us say that both ants, or both, let's just call them people, both people walk abreast of one another. Now, what does abreast mean? Breast. What do I mean by, here's what what sort of formal definition could we give to abreast?
I'm not sure what you're describing by abreast.
Oh, it's just, I mean, like they're walking like together, maintaining this. I'll just tell you my formal definition. You'll get what I'm saying. So if each of them have a straight line before them and that's the direction they're walking, and then they take a 90-degree angle, they both maintain that 90-degree angle relationship to one another. That's what abreast means. Okay.
Yeah.
It means like the breasts are both like with one another.
Yes.
Okay. So in order to walk, so the difference in geometry is that in order to continue walking abreast of one another, one of them has to walk less distance.
Continue walking abreast of. Yes, correct.
Which is not the same as Euclidean geometry, because in Euclidean geometry, they have to walk the same distance to stay abreast of one another.
Yes.
And so as you can see, this is a very clear difference in the way your spatial relationship changes to another thing when you change your spatial relationship to some third thing.
Uh-huh.
And so, okay, now, here's something else that's weird to think about. Imagine that there was a gentleman standing on the equator. I'm sorry, standing on the North Pole.
Yeah.
Okay? Here he is. And you walk around and you walk, east. He's walking east in this picture. Then then tell me what's the weird thing that would happen?
No matter where you go, you will still be the same distance from the gentleman at the North Pole.
You will be the same distance, and he will always be abreast of you.
Abreast of you, yes, correct.
That's pretty weird.
Yeah.
So once again, I think you get this, but the whole point is that it's the rules of space that are different. It's not that you're literally on the surface of a sphere. It's that the rules of space are now different.
Right.
Yeah. Okay. Now, what the hell could this how does this relate to the plenum? Here's how. Let's see if I can.
We'll bring it all together.
I challenged myself.
Yeah.
Mentally. I was mentally challenged. No, I challenged myself to conceptualize space without using space.
Got it.
You can, and it sounds like you're already intuitively with me here, but let me explicitly say why I thought that was a good idea. Because it kind of sounds insane. Actually, can either of you think of why this is a good idea? Let's make this a philosophical exercise.
I mean, you're trying to differentiate certain types of spaces. So you'd need to say, what do they have in common?
To be categorized as a space.
I haven't explored that reasoning. That's probably a second good reason to do this. Here's my reason, unless you guys want to guess one more time.
Huh. I was
good reason.
I was pretty sure Sean got it. Okay. Let's see.
He probably did. That sounds like a good reason. I just had a different one.
All right.
Yeah. I'd have to think about it to make sure, but that sounds correct to me. Yeah. Anyway, here's my reason.
Okay.
Yeah.
My claim is that space is an emergent property, that it's caused by some deeper nature.
I see.
You're already seeing it. Like, if you want to explain how space is caused by a deeper nature, you can't make reference to space when explaining how a deeper thing causes space. Okay, so I wanted to explain space non-spatially. Okay, it turns out Leibniz probably already thought of this, by the way. I thought of this myself, but I think Leibniz, I need to read, there's these critical dialogues between Newton and Leibniz about the nature of space. And from what I understand, both of their views have flaws, but I'm sure it's brilliant. I'm sure there's tons to be gained from that. I got to read it sometime. But anyway, so here's my view. Here's the way I thought of it. How do I explain space non-spatially? So first of all, the way I thought of it was, okay, I'm going to imagine the plenum, as being a bunch of buckets. Here are the buckets, okay? And the buckets are allowed to transfer their water to the neighboring buckets, okay?
Yes.
So this is a very crude way of thinking about the ether. You know, the water would be quantum fields, and the buckets are just parts of the plenum. Okay? Yeah. Now, I have thought of space spatially, right? This is still a spatial picture.
Yeah.
Can you think of a way of preserving the important part of space while not making reference to a spatial image?
I don't know. At first glance, I'm not sure.
Well, I would encourage you to not glance, because glancing involves space. You're seeing something laid out spatially. I don't know. That's a stupid hint. What do you got?
Repeat the question one more time.
The question is, how can we conceptualize space without using? Remember what I thought what I think space is. Well, I think the evidence only tells us that space is the rules that govern whether two entities can act on one another or not.
Yeah.
Okay.
That's what space is. I don't think there's any evidence to support additional aspects of space. Mm-hmm. You know, Newton thought there was an absolute space, right? That you're basically moving around in a cosmic container. That could be true, but there's no evidence for it. Well, it isn't proven. That is one of the stories that's consistent with what we see. It's kind of the most naive story. But we haven't proven it. All that is proven is what I said. So how can we understand this aspect of space without making reference to a picture like this, where you're saying, oh, well, how do I know this one can transfer its water to the other one? Well, it's next to it. But you're using space. Yeah. So how can we think about this without reference to space itself?
Huh. Does no. Yeah, but it's...
People on the recording, you can pause the video and puzzle this out yourself. You can even leave a comment so we can see what your guesses are.
Yeah, there's people struggling along with us.
Yeah.
Yeah, this is really difficult.
So something about interaction, or acting upon another entity. I'm taking something with the word relationship. I'm still so far away from it though.
Okay, so here's how I think of it. Instead of drawing the buckets as being spatially related, I draw a bucket and then a comma and then another bucket and a comma. Okay, now what the hell does this mean? I mean, this bucket exists, and this bucket exists, and this bucket exists, and I'm not going to think of them as spatially laid out. They are things that exist. Okay? Right. And there's rules written on the side of each bucket telling you which other bucket can transfer its water to. So this is bucket 1, bucket 2, bucket 3, and bucket 1 can only transfer its water to, let's check, 1, 2, 3, 4.
Right.
5,
At this stage,
6.
we're not even saying anything about space at all. We're just writing stuff, or we're just saying each of these entities have rules
Yes.
about what they can do. And from there we can say,
Yeah.
well, from this we can derive the idea of next to, because next to really just means entity can do this.
Yeah. Yeah. So I've written on the face of bucket 1. I've written only 2 and 4.
Right, makes sense.
Yeah. So okay, now, so what might it mean for an alternate geometry to apply? It means that there's a plenum,
Yeah.
that quantum entities, that entities are waves in the plenum, that they can change their location from different parts of the plenum to the others, and
Right.
certain situations change the relationships between the transference relationships between the plenum parts.
Yeah. I see. That makes sense.
That is the wild fever dream hypothesis.
Yeah.
So you have the whole thing now. That is, it's a hypothesis.
Right.
But I think there's real value to it though, because what I've done, like I don't want to, I want to be properly modest. Modest is the wrong word. I want to be properly epistemically conservative in saying this is just a hypothesis. I haven't proven anything here. But I want to make sure this gets the credit it's due. I think it's due some credit here because it's worth considering, because what have I done? I've stripped my approach to these phenomena of all assumptions, of all things that are plausible, but we're not sure of them.
Yeah.
Specifically, like we know about space, we know about general relativistic phenomena, we know about some stuff, we know about all these things. And, you know, I gave you this earlier hypothesis, which is of course plausible,
Yeah.
but it makes certain assumptions that
Right.
don't need to be made. So by stripping down the assumptions and reducing myself to only things that I know to be true with certainty, this alternative arises.
Yeah.
And unless I've made a mistake, which I might have, I might be missing some details or many throughout the process here. A lot of this hinges on a deeper understanding of the physics than I have. So I have to make that caveat. But assuming that none of those mistakes were made, I think this is a more likely candidate than the other approaches.
Yeah.
So, yeah. So that's what I got.
Yeah. So space in this case is just the relationship between, what do you call these things? These 1, 2, 3, 4, 5, 6.
These are ether buckets or plenum buckets.
Plenum buckets.
Plenum cells, maybe.
So space is defined by the relationship with how these plenum buckets can interact with each other.
Yes.
I see. If I were to ask you, what is the definition of space precisely? What would you say?
I've given it a couple times already. Let me try to, but maybe not super precisely. Let me try to be as precise as possible.
I feel like
well,
you
I have it written in my broad physical categories document, actually.
Okay.
Go to the theory of induction and then just go to space. That's the best definition I have right now. It's
And
something like this, though. In the meantime, while Arshad looks for it, it's
I see.
a relationship between entities which determines whether those entities can act on one another.
Yes. Okay.
Okay.
Yeah.
Yeah. Makes sense. Sorry.
Yeah. Okay.
You said that like 4 times this call, and I still forgot.
Likewise. All right.
Yeah. No, that makes sense. Okay.
Well, that will give us plenty to work with. I don't know. Well, so sit with that, and I'm sure it'll lead to something cool.
Yeah. For
Yeah.
sure. We'll.
I'm not sure, but anyway. Hopefully
Yeah,
it
yeah,
does. Give it a try.
Yeah, for
See you
sure.
guys.
We'll
Yeah.
connect with you. We'll set up something to connect
For
with you
sure,
after.
for sure.
Yeah.
Sounds good. All right. See you guys.
See you.